So now let's finish this worksheet with this second reaction. This is an opportunity for us to practice a secondary amine as our nucleophile. And we are using sulfuric acid as our acid catalyst. So step one in this reaction always is to protonate the oxygen. And we are going to end up with positive formal charge on our oxygen, which makes the oxygen excited, or excuse me, makes the carbonyl carbon excited to react. Now the lone pair of electrons on the nitrogen are going to come up and attack the carbonyl carbon and open up the carbon-oxygen double bond. And we are going to, in that step, we are going to have now an OH group, because we've opened up the carbon-oxygen double bond, and we have created a bond to our nucleophile, a nitrogen with one hydrogen and two methyls. Because that nitrogen has 4 bonds, it has a positive formal charge. We are going to use the conjugate base of our acid, HSO4-, and we are going to grab that hydrogen off of the nitrogen to get rid of the positive formal charge. And we are left with this lone pair of electrons on the nitrogen. That, when we did that, we created H2SO4. I like to write it H bond HSO4. And so now, because we have a strong acid in the presence of an oxygen, we're going to go ahead and protonate that oxygen. That's going to give us a good leaving group, water, and our nitrogen with 2 methyl groups. The water molecule is going to leave, and the lone pair of electrons on the nitrogen are going to come down and form a carbon-nitrogen double bond. That does put a positive formal charge on the nitrogen, but we can't fix that positive formal charge by removing something from the nitrogen, because we cannot remove any of the alkyl groups off of the nitrogen. So to take care of that, if you remember, we're going to use our conjugate base again, HSO4-, and we are going to abstract a hydrogen from what used to be the alpha carbon. So we're going to pull a hydrogen off from either one of these carbons. And because this molecule is asymmetrical, the molecule has to choose which hydrogen is going to come off. Are we going to remove one of these guys? And if we do that, we're going to be making a double bond right here. Or are we going to remove this one? And if we do that, we'll be making a double bond over here. And so we have to ask ourselves, what would this molecule do? What would make the most sense? We're still going to be following the same types of rules that we follow anytime we're forming an alkene. When we form a carbon-carbon double bond, our goal is to form the most substituted double bond, because it's the most stable double bond. So we want to grab this hydrogen right here and put a double bond in this position right here, which will ultimately give us the most substituted alkene. And that's our product.